vector is just basically Postgres vector, right? So these kinds of databases, they are meant specifically for LLMs to function. Okay. All right, I see. Okay, never mind. I won't go through the previous parts anymore. And then, okay, after you have the embeddings, right, everything to numbers, right, then only you can do the retrieval. So basically, retrieval is about finding the most relevant pieces. LLM will look at your prompt, and then, right, because your prompt will also be converted into tokens as well, right, because it's text, and then the text converted into these embeddings, and then, right, it's just mix and match based on math, right, which tokens, right, they have the highest matching with these embeddings from a document, which has the closest match. So it's all embeddings. And then the most relevant ones, they will retrieve them. And then they will do the full RAG workflow. So once you retrieve the embeddings, then these embeddings are used to augment the response from the LLM. So instead of hallucinating, it will have a more grounded, accurate answer to your prompt, and then generate the response from the LLM. And then we just package everything into an interactive app. Okay, I think in my code base, later that we'll see, I don't have the time to make the front end, but then I think just the back end, we just probably using terminal, it's enough. Yeah, so we can just package everything into a decent UI for people to use. Okay, fluent isn't the same as informed, right? So just like what I mentioned earlier, so the LLM, right, can also hallucinate, basically, right? It can just, how to say, dump a lot of cool looking words and really accurate looking terms, but then it may not be correct. So this is the risk of using AI, basically. AI safety. Actually, RAG is also, if you think about it, it's part of AI governance, making sure that AI is reliable, it's safe to use. So otherwise, otherwise it can just anyhow give an answer. Right. So what we want is whenever it's not sure about an answer, right, it can do something like actually saying, right, I don't have information about a product called the Skylab 3, right? This is just an example. Right. So it should have a confident guess. Right. So whatever it says, right, there has to be like this confidence score for every response. For RAG, we don't really score the response. That can be part of a bigger workflow in AI safety. So that's an entire story already, and another topic for another day, like AI safety. Okay, so in my code base later that we'll see, right, I have 3 markdown files for the LM to read, and it's just packaging this workshop like to make it more grounded, I guess. So yeah, so imagine, right, we are in a company called Nimbus Robotics, and then there are 3 markdown files that we put into the vector database, basically give it, and then for RAG. So there's one file about employees, one file about the product, one file about the security surrounding our products. Okay, so these are all markdown files prepared for the model retrieval. Okay, so this is now number 1. Okay, so basically this is inside the code base. I'll just change my screen now. We'll see like what the LM does when it's only the LM itself. Okay, I change my screen. Oh, okay. To share, choose a different screen. Oops. Okay. Right, show my screen. Oops. Okay, I go to this one. Okay. Yeah, in fact, right, if you guys want, you guys can clone this repo as well. I'll just share the link. So back to here. Oops. Okay, in the chat, right, I just share the repo. NanoLabs / what's that? Right. Okay. If it's the HTTP URL, wait, what's that? GitHub.com, right? Now lab slash rec workshop dot git. Yeah. So depends on what you're using lah. The GH CLI or Git CLI. Okay, so yeah, feel free to clone it. Just play around inside the your IDE. Yeah, but you can just look at my laptop as well. Look at my screen. Okay, yeah. So this is my IDE, and I'm opening the repo here. Yeah, so on the right side, right, as you can see, yeah, if you can't see, just let me know, just voice out, because I'm showing my entire screen. And then in the steps folder here, this is where each step of the rec workflow is like divided into. So at first we have the naive LM file, number one. Okay, I just got a message. The git is empty. Oh, wait. Oh, yeah, sorry. I forgot to push. Okay, thank you so much for reminding. Right. Wait, I just push now. I want to exit the virtual environment. Okay. And then git add, git commit. Audit the repo, git push. All right, cool. Yeah, just check it now again. Tell me if it's there or not. Yeah, and if you can like just clone it. All right. Yeah, I'll just go back now. All right. So imagine we now ask the LM without any documents given. I'll just make it bigger. Okay. Right, so it can search the web, right? But then everything can just hallucinate. Right, and it may not know anything about your specific company, your specific documents. So FYI, I put the documents here in the data folder. Okay, so the data folder contains the 3 markdown files that I talked about. Okay, yeah, again, it's fictional, this one. Also, FYI, right, I actually created all these files, right, using Codex. And so everything can be so fast, like even for this workshop. So like Cloud Design for the slides, and then Codex for the code itself. But before that, I also use Opus, Opus for the planning. And all this is done in like 1 hour like that. So I really highly recommend to try out these tools if you haven't. Like everything can be sped up really fast. Right, so just a fictional company overview. Right, so again, this is the markdown file. Right, and everything here, right, it's specific to our company, Nimbus Robotics. Work hours, remote work, okay, everything is the markdown file, properly written for the model to know. Right, security policy as well. Okay, just like headings and the body. All right, and the specific product about Skylark 3. Okay, oh, it's a warehouse robot. Okay. All right, back to the steps. Okay, ask the LM without private context. Okay. All right, so all the logic, right, for the rec, right, is abstracted into another folder, which is rec. We can have a look into it later. Okay, so we're going to pass in this question. So it's just a hard-coded question. How many Nimbus days of vacation do Nimbus Robotics employees get? So usually, right, what we humans will do, right, we will just go into document, right, like go back to employee handbook file, and then just find this vacation policy, right, which is 18 Nimbus days. I think that's the only answer. Yeah, remote work hours. Yeah, right. This is the answer that we want. Vacation policy, 18 Nimbus days. But then, right, imagine yourself, like, why do we use rec again, right? Because it's faster, right? When you have a lot of documents, and then just one chatbot in your your whole company platform or something, right? The company dashboard or something, and then you can just ask and get the info straight away, right? Instead of getting lost in like so many documents, right? So when we ask this question, okay, just pass in the question, and then okay, this is actually hard coded, but I haven't got the model to be working. But basically, it's like there will be a lot of different answers to it, right? So, no module name .env. Oh, okay. Oh yeah. Okay. Cool. 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 All right. There's some bug inside, but yeah, I think I'll just skip this. Right. Basically, the model, right? Right. When there's no context, right, then it will just get answers from everywhere else, and then you wouldn't get the correct answer, which is 18 Nimbus days. Okay. All right. Okay. Cool. Yeah. The repo is there. Okay, but again, it's like, yeah, I just saw like some bug in the first file. So yeah, there's still something to work on. But I'll just push when it's ready. Okay. So back to the slides. Um, oops. Okay. Yeah. So the for just a basic LLM, right, it wouldn't get the exact answer of 18 Nimbus days. Right. That's the answer we want. Right. Okay. This one also same thing as well. Okay. Right? So everything here is ungrounded lah. Without the private information, the context around our company, right? Then it will just anyhow give an answer. Okay. Yep. Basically, just get the context. Okay. Now we'll see like how it does the chunking. Okay. This one, I think it should work because it doesn't need like any model API key. Instead, um I think after this, I'll just change the API key quickly so that it will work. Maybe use some other model. But then for this one, this second part of the RAG workflow, right? Chunking is just, it's just surgery on the document. Just cut and cut and like organize everything into chunks, right? So we're gonna see how it works under the hood. So back to the code, right? Okay. I hope this one is okay now. I actually run it before this. Okay, so when we run Python, right? Okay, definitely also just make sure that you're inside. Oh, all right. Sorry. Yeah, I forgot I'm not in the virtual environment. Oh dear. Okay. Source VNV then activate. Right. Okay. Right. So for the second file, wait. Oh, sorry. The right. Okay. Now this is a bit long. Okay, so I ran the second file, right? It's a Python file. So what it does is get all the three documents that we have in the data folder, and then it created 14 chunks. Okay. So every single chunk is like one small paragraph or something. So basically, one chunk after the first chunk is like the first paragraph, and then chunk two, right, starts at word 50. So the second paragraph or something, and then so on and so forth. I think it's only for employee handbook. Yeah, I think we kind of like shorten it. All right. So this is what chunking does. We can also look into the code for a while. Okay, so this is the chunking file. Okay, so it gets the documents from the data folder. And then there's a specific function for this. Just put in the chunk function. Oh, again, yeah, because we abstract the logic into the red folder. Yeah, but we'll see this later. Okay, so basically everything is chunked. Okay, the whole markdown file that we saw earlier, employee handbook, right? First chunk, second chunk, third chunk, fourth chunk, and so on. Okay, and then we will go to embeddings. Okay, right, just checking if there are any messages. All right. All right, cool. Okay, now we'll go on to, yeah. Yeah, so we went through this already. Few words to the next. Yep. Okay. So after chunking, we get the embeddings. So we turn the words into numbers. Okay. And this is where we go to the third file. Back to the code. Okay. Let me see if it's working now. Okay, so just run the third file, step/03 embeddings pi. Oh, it's working now. All right. Okay, also just FYI, right? I actually use an open router model. Yeah. So if you want to also, you can try it out once you have the code. Yep. Oops, sorry. Just keep on switching. Hey, sorry, where am I? Yeah, this one. So the .env.example file, right, is the env file you should copy and paste, make your own .env file. Yeah, so basically I'm using Open Router, a free model. So I'm using GPT OSS 20 billion parameter model. Right, there's a list of like the different free models on Open Router, like especially for those right who are new to Open Router. So it's actually just what's that? It's basically a model as a service company. So you can use any model, OpenAI, Anthropic, everything, right, using just one API key. So in your code, right, you just need to let your code know that which model do you want, right? Open Router chat model. So in Open Router, I'm just using a free model. Like, how do I go to? Okay, price low to high. Okay, never mind. I just search OSS. There are a whole lot of like models from free to the most expensive ones in the world. So I'm using this one, GPT OSS 20B. This is quite good actually. So it's free. So you're not paying anything through Open Router. So this is the Open Router is the platform that I recommend to people if you want to just just play around with models for free. Okay, back to the code. Okay, so I ran the third file. Okay, so right. Okay, this is going to get a bit technical, but basically how embeddings work, right? It's all about matching, right? You want the closest matches as possible from the documents. And so this matching, this similarity in math or in CS, it's called cosine similarity. Okay, again, we're not going to cover this. It's an entire story already in math, cosine similarity between phases. Okay, so basically the highest matches, right? And this is I think it's the probability score or something. So the higher, the better, right? So which one is the highest? We see that it's 0.697, which is, wait, what did we ask again? Wait, I go to the third file. Okay, so this is the embeddings file. Oh, I see. Okay, so we want to check like the embedding score for these four phrases specifically. Okay, and that works as well. So what we can see is when we want to find the highest matches, right? Warehouse robot charger, for example, which one has the highest match to this phrase? And we see that it is robot battery charging dock. And it's common sense, right? So from a human perspective, this is the closest match as well, right? Robot charger, robot charging dock. Okay, but I don't know where the document is, but we don't need to care about that, right? Especially when there are so many documents. But what we care about is getting the most relevant answer. And this is really relevant. 697. And then, okay. And then definitely, right, it's a low score for, like, if we put vacation days for robot battery charging. Okay, I think the file is actually doing some test run or something. All right. All right. Okay. Awesome. Okay, so this is for the third file. So basically, this is how embeddings work, right? Just converting all text into numbers and then find the highest matches. Okay, so I'll go back to the file on the slides. Okay, so embedding is just all about numbers, arrows in space. Oh, okay, now this is already towards the math side of things. Yeah, but actually, yeah, if you want to look through it, okay, I'm just going to like pause for a while, right? Cosine similarity, making sure that the vectors are as close as possible, right? The closer the better, because it means the words are more similar. Okay. Yep, and then we give a score like what we saw earlier. Okay, and now we have all these scores, right? From all these numbers, we compare these different texts, right? Their embeddings, and then we got the ones with the highest matches. Now, what we do now is we retrieve, right? So for the model to answer the human, right, it gets all these highest matches to augment its answer. So vector store retrieval. Vector store is the database of all those embeddings. For now, we are not implementing a vector database. That will be for the next workshop. But for this one, yeah, just like some three documents, the markdown files, and then just kind of like convert them into embeddings for retrieval. Okay. NumPy vector store. Right, so we're just going to use a simple file inside the rec folder, vector store.py, to do the chunking and the embedding, and then kind of like just store them somewhere. Okay, this is inside the rec folder. We can just look through it in our own free time. Okay, so what's going to do, right? Is that every single chunk, it will have a score, like what we saw earlier, right? In the third file embeddings. Every chunk into embeddings, and then you'll have an embedding score, right? Matched with the prompt, the human prompt. And then we're going to get the top chunks, right? If we specify K is like 2, right? Then it's just like top 2 chunks. Right, so it's in our code. It's abstracted away from the user. So we ourselves define like, okay, how many chunks we want for the augmentation. Maybe like just the top 2 chunks. All right. Okay, same thing again, because these two are the highest matches. Okay, the top 2 chunks. All right. Oh, okay. I think you just skip the fourth file, but never mind. So we're going to see the fifth file. Okay, in the steps, right? The fifth step. Now we're going to do the whole rec workflow. And we just combine everything together from the documents, become into chunks, become into embeddings, and then get the similarity scores, and then retrieve, and then generate. Okay, I go back to the code base now. In fact, I think we can just look through the step 4 first, because I think we just skip this. Okay, this is the retrieval part. I see. Okay, I'm just going to run this and get everyone to see what it's like. Python step / yeah, also by the way, make sure when you run this on your own PC, right, make sure it's you're in a virtual environment, okay, to get the all the the packages in Python, right? All the steps are also here as well. The README file, the repo root README file. Yeah, okay. Just set up your virtual environment and install the necessary modules lah. All right. So I go back to the third file again, embeddings. Okay, Python steps / retriever. Step 4. Okay, so this is a lot of text. Wait, right. So where were we? We were at, okay, here. All right, we are here. Right. So we just ran the step 4. We retrieve the embeddings. Now, when we ask the question, how long does a Skylab 3 battery last? So again, this is like, it's just fictional. We're just giving like some context, right? We are the company, robotics company, and then this is our product. We have to know like how long does this battery last, right? Imagine you have so many documents, right? You just want just want the most relevant answer. Okay, and so what happens is you're going to rank the documents. So rank 1 is, what is the best matching document that we have, right? It is Skylab 3 FAQ. And this is really common sense, right? Because if you look back at the data folder that we have, the 3 markdown files, right? right? So if you can't see my cursor, just let me know, right? Top right here, we had 3 uploads, right? And then Skylab 3 FAQ.md is one of the files. And then if you look into it, okay, just remove the terminal, right? So is there anything about the battery, right? So it's here, battery life. So it's the best match already. And this means our, the RAG workflow, the retrieval part is working, right? So it gets the right answer, which is 9.5 hours, this battery life section. I think just a closer look into the actual code, right? What's going on inside the retrieve .py file, right? So we can see here, okay, again, like all the RAG logic is inside the RAG folder. Okay, but basically, it runs the retrieval part, right? So when we chunk documents and then embed, right? So everything is ordered neatly, right? Properly from the start to the end, right? Documents, chunking, embedding, and then, right, store inside a vector store, right? So we just implement a simple function to put everything into a vector database. And then the question also become an embedding, right? The user prompt. And then we search the database. Okay. I think the search function is, store.search. Oh, okay, this is a specific method under the import. Okay, never mind. Okay, so we're using some third-party import, I think. Yeah, vector store. All right, and then so we search, and then we print out the result. Okay, so I think just a quick look into the RAG side. So because so many things are inside the RAG folder, maybe in vector store. Right, so if you just look inside the RAG folder, okay. Oh, we define our own vector database. All right. Okay, vector database. So everything is actually working as expected. So again, we convert everything to vectors. So this is how we do it. We normalize the vectors. Okay, and anyway, we don't need to memorize this. Basically, just understand what's going on behind the scenes. And we can see that the RAG workflow is actually working. So everything, right, the text convert into numbers, basically. And then when we search, right, yeah, we search also based on the numbers. So first we normalize again. We change the English, right, the prompt right, into vectors as well, right, into the embeddings. And then give a score. Okay, a normalized query. Okay, and then sort it as well from lowest to highest score. Okay, so just want to let everyone see that, okay, everything is not hard-coded. Every calculation is actually made inside a retrieval workflow. All right, so we just go back to the terminal. All right, so we have the highest rank. I would say it's not that high as well, 0.673, but then, right, we just do with the best that we have, and then it lasts for 9.5 hours, so everything is correct, right? So you can see that when we ask the LM now, the answer is grounded. It's not hallucinating. It's based on the files that we actually gave from our company. Okay, there's something extra as well. What charging users, how to do Slack Mini. Okay, Luma Ring and some more. Okay, we can also add in further refinements for the model output, right? Maybe like get it to shorten its answer or something. We can do that as well, but that's for another day already. Okay, and then rank 2, right? There's a lower score. And why is it lower score? Because it doesn't talk anything about the battery. It's just going through like, what is Skylab 3? Like just a basic intro. And again, like, why is there even like this rank 2, rank 3, right? It's just basically to see like if there are any other candidates, like any other chunks, right? The embeddings to augment the answer. So it's all just like the best practice of RAG as well, right? Just rank all the documents, see which are the top ones. And then definitely the lowest rank, right, is what warranty. Okay, so this is definitely not about battery. So this is the lowest rank. Okay. let me just go back to the, okay, no questions. Right, so anyone have any questions, right, just let me know. Yeah, because I need to keep switching screens or just voice out. All right, I'll go back to the slides again. Right, so what we saw earlier, oh, okay. Okay, just now we saw the step 4, the retrieval part. That we're going to do the whole RAG pipeline, right? Retrieve, augment, generate. Okay, back to the code. Now I'm going to run step 5, which is the last step. Rag.py. All right, so this the last file in the steps folder where we combine everything from the start to the end. Okay, you upload document, right, and then convert to chunk, convert to embedding, and then get the similarity score, compare, get the ranks, and then use the top ones, right, to augment the answer. Let's go. All right, so it's generating. Right, so just give it some time. I mean, it's a cheap model, so cheap model, so it's a free model even. So yeah, it will take some time. Okay, so what we have for now. Okay, yeah, so it's correct, right? 18 Nimbus days. But let's go through from the start to the end, what's actually happening behind the scenes. Okay, this is a very long answer because we're doing the entire RAG workflow. Let me just find the command again. Wait. Where is it? Wait, am I? Oh, here, sorry. Yeah, okay, so we were here. Okay, so actually it's quite short. And that is a good thing actually. Right, so we just want the final answer. We don't want to look through all the calculations from the LLM, right, and the embedding model. Okay, so when we run the command, right, we put in the question, how many Nimbus days of vacation do Nimbus Robotics employees get? Right, and then okay, this is just a quick demo as well for the first part, where we see that if it's just the LLM, right, it's a free model from the open router free model. If it's just LM, we don't give it the context, right? Then it says, I'm sorry, but I don't have that information. And that is really good, right? In fact, the fact that you can put something like this, right, it's really good because it's not hallucinating and we're not getting any wrong answer. Then we move on to the full RAG. Okay, retrieve Nimbus Robotics context. And then it says 18 Nimbus days. And that is correct, right? Based on our markdown file earlier. Right, so we just go back to the employee handbook markdown file. Right, so vacation, right? So all employees have 18 Nimbus days of vacation every year. And okay, that sounds good. 18 days every year. Okay, back to the terminal. Right. So if we're going to see like what's going on inside the RAG file, right? Step 5 over here. Okay, just to make sure that everything is not hard coded. Okay, again, because everything is abstracted in the RAG folder pipeline. Okay, we'll look at this after this file. Right, so this is the question, right? It's hard coded, the question. Right, but let's see the computation. Okay, everything is actually still inside the RAG folder. Okay, RAG pipeline. Okay, now we're inside the RAG folder, the pipeline file. Okay, now this is going to get a bit longer. Let's find that specific function. Post chat. Ask plain LLM. Okay, right. So this is the pipeline. We first define the class. Okay, and then we have the vector store as well, right? From the documents, every single chunk is stored inside here, right? So it's a vector store class, right? The embeddings are done and then stored inside the pipeline class. Okay, right? And so this is where the magic happens. Inside the pipeline class, right, there are these specific methods where we do the computations for the similarity score, embed text, and then we search as well for the top results. Okay, again, because these functions, right, they are inside the other, the rec files that we have that we defined earlier. Okay, but we can look through that in our own free time, right? So the calculations are done here. And then this is where we put in the user question, ask. Right, so get the question, get the top results, retrieve. And then just basically prepare the final result for the human. And definitely also for just like any standard practice, right, in prompting in LLM, there is a system prompt for the very first message for the context. Okay, and then for the response, right, generated. Okay, so definitely put in the system prompt inside the first message, and then second message, the user question. And then we just keep on adding on and on in the conversation. Okay, this one, we're not cover that detail. We covered this before, right? And then return the response. Right, so as you can see, everything is based on the RAG workflow. Everything is calculated, making sure that it's the best match. Okay, retrieve function here. Okay, so that's the key. Everything is based on the documents that we uploaded. All right, so for the other files, feel free to just look through them in your own free time in the RAG folder. Yeah, in fact, there's nothing wrong with the code anymore, no bugs. Actually, it's just the just make sure that when you run the files, right, you have the API key from Open Router, and just to save money, you can make sure that it's the free model, right? So in your .env file, right, make sure that you define your free model. Okay, I think apparently you need to define free as well, :free, and then put in your, okay, this is my API key. Oops. Okay, yeah, and then Open Router API key, put in here, right? And then when you run the files, right, every file inside the steps folder, make sure that you're inside the virtual environment, okay, to get the specific packages from your virtual environment folder, okay? Must activate your virtual environment. And that's it. Let me go through the last slides. Okay, right, so we saw this already, retrieve, and then use it to augment the LLM's answer, and then finally output it, right, generate. The only difference, yeah. Okay, so actually, right, the whole thing about RAG, right, is actually just context. Hey, whoops, okay, right? The whole thing, right, the whole idea of RAG, right, is the context, right? It's common sense, right? Because you need the company context to answer company questions, right? Company-specific questions. And this ties back, right, into the bigger picture of AI, right? Agentic AI, especially, what's the most important things, right, you need to have, right, to build an agent? Number one is the brain, the LM, right? Number two is the harness. Harness, right? There are all these tools, right? Like whether it's like browser use, right? You let your agent run loose, right? Buy your items from Temu, from Shopee, like Taobao, like in China. Or you can also get your agents to do the coding, code, codecs, right? That's the harness. And number three, right? You need to give it the context. So context, right? There are different things. Number one is the persona, the system prompt that we saw, right? Who is this agent? Who are you, right? So just now we defined earlier. I think just go back again. Where were we? The RAG pipeline, I think. Yeah. Right. So we just go back, right? Right. The system prompt. We have to give the this specific agent, right? Yeah. Actually, it's not an agent even. There's no tool introduced. It's just Gen AI, right? The chatbot, right? This RAG, right? We tell this chatbot, okay, you are this company something. Okay, answer questions about Nimbus Robotics, right? And blah blah blah. So that is the context about the chatbot or the agent, and the context also includes the previous conversations. Okay, so that's the context. And so these are the three main things to building like this chatbot, to building an agent that actually does reliable work for anyone. Okay, so rec falls under context. Okay, right. The interactive app. Oh, okay. This is for some other day already. Yeah, I can just try other questions. Yeah, in fact, just feel free to change the question inside the code because I hard coded the question lah. I think in steps. Yeah. So you can just put inside the question here. Yeah, just change the question inside the steps. The file number 5, right? This question, right? This is just the one for demo. Yeah, I think the other parts are not. They shouldn't be hard coded. Yeah, correct. Yeah, so feel free to try out, right? Just try out any other question. But in fact, since we have time, right? I think I'm just gonna try out another question to let you guys see that it's actually really cool, really powerful. This rack pipeline. Okay, let me just charge my laptop first. Okay. All right. Yeah. So I'll just change this question now. Okay, maybe like, what is fork-bound data? Let me just try this question. Let's go. Okay. Yo, what is fork-bound data? Okay. Now I changed this question, right? And I'm going to run the file number 5. Okay, let's go. All right, again, be patient with this free model. It will take some time. Actually, I think also, right, either free or not free, it will take some time as well, because need to do the chunking and embedding and then store inside the database, right? And then retrieve it. So definitely will take some time, regardless of the model. All right, so as we can see, it is accurate again. Where did it get the data from? It got it from IT security policy. And is that a file? Oh, whoops, my battery low. Okay, right. So is this a file? Yes, it is a file, right? IT security policy, top right. And what does it say? Fork-bound data is our company's most sensitive private information, such as unreleased robot designs and customer warehouse maps and blah, blah, blah. Now, you ask, is this correct? So we go to IT security policy. Okay. Wow, this is a whole lot of information. But just for human verification, we find the relevant specific part. This one. Okay. Right. So under the heading data classification, fork-bound, sensitive private data, including unreleased robot designs and customer warehouse maps. So this is correct. This answer is reliable. So this is how RAG works. All right. Okay. I won't try the other questions now. Whoops. Back to the back to the slides. Right, you can try it again if you want to, like, how long before laptops log, what is Nimbus robotics stock price? Oh, okay, this is not in document. Yeah, you can try a trivial, how to say, the border case as well. Yeah, try an edge case and you can see that it's not working. When there's nothing to retrieve, it emits it. Yeah. Okay, so this is the safety that we want to ensure, right, before we actually use it, right? It wouldn't hallucinate. Okay, and also definitely, this is something very important to know for AI. RAG doesn't train the model. So the fact that we are using the brain already, right, it means that it's after the model training, right? So because we are calling the model right from Open Router, if we are training the model, we can't even use the model in the first place, right? We are still doing all this, like, what's that? It's like preparing all the data sets and then like tune the parameters of the model. So that is an entirely different thing already. So that's even before like we use the model. Okay, so RAG definitely is not about training the model. We are already using the model. Okay. All right, and definitely RAG is just one part of a huge of of this huge picture of like context of building chatbots, definitely there are many other different things that we can look into, right? Definitely AI safety, right? Monitoring the audit trails of the chatbot actions, access control evaluation, right? So there are many other things inside AI. All right. So this is the end of the slide. Just a catchy phrase by Cloud Design. Yeah, again, so I actually did this using, whoops, how do I go back? Okay. Yeah, so I did this using Cloud Design, and yeah, I'll just stop sharing my screen now. It's 8:58. Yeah. Whoops. What did I just do? Um uh yeah, so this is the end of the workshop, and thanks everyone for joining. Yeah, feel free to stay tuned for next workshops. Hope this RAG workshop it gives something meaningful for you guys. Yeah, so there are no bugs. There are no bugs inside the code. Make sure virtual environment, make sure API key from your open router. It's free, right? It's free. Just sign up for the account. Yeah, I really recommend it for free models. All right, thanks everyone. We'll stop the recording now.